Let's look at another example. According to the National Center for Health Statistics, 15% of all Americans have hearing trouble. Part A. In a random sample of 120 Americans, what is the probability that at most 12% have hearing problems? So right now I'm seeing probability. So you should right away think probability, and then we're going to fill this in. So what does at most 12% mean? So 12 is the highest, so less than 12%. You can do equal to sign here, because if you remember at the very end of chapter 7, it does not matter for continuous data if we put an equal sign here or not. And then what are we looking for here? Well, this is a proportion, right? So you have to do P, and we're doing sample proportions, so you have to do your P hat. So since we're looking for the sample proportion, you have to use your corresponding mean sample proportion and your corresponding standard deviation sample proportion. So your mean is going to match the proportion, and the standard deviation, you're going to follow the formula up above. So 0.15 times 1 minus 0.15, all divided by 120. So she had 0.032596. So we're working with probability under a normal curve. Well, is it normal? We better check that first. So we have n, which is 120, times p times 1 minus p. That is equal to 15.3. So that is normal. And we can say 120 is less than 5% of your population of Americans. So that's satisfied as well. So then we can go ahead and use number 6 on our calculator sheet. So second bars. Our lower bound is negative 9999 because we're going to the left of 0.12. Upper bound is 0.12. Mean is 0.15. And your standard deviation is 0.032596. 0.1787 is your probability for that. Okay, let's move on to B. Suppose that a random sample of 120 Americans who regularly listen to music using headphones result in 26 having hearing problems. What might you conclude? So let's get to another page here so we have some room. So it's not specifically asking here what to do, but if we test to see if this is unusual, then we can make a statement about that. So what I'm going to do is test to see if it is unusual. So if you recall from chapter 6, unusual would be your mean plus or minus 2 standard deviations. If it's outside that, then it's unusual. Or chapter 5, if it's less than 0.05, it is unusual. All right, I'm going to do both just so you get exposure to both of them. Okay, so for this we can do the mu of p hat plus 2 times sigma p hat. That's going to be 0.15 plus 2 times 0.032596. So that's going to equal 0.2152. And then if we subtract, So now we want to know, we have sampled 120, results in 26 having hearing problems. So below we were working in proportions. Do we have a proportion yet? We do not. So let's put that, make that into proportion. So 26 out of 120, that's 0.217. Now if you want to think of this as on the normal curve, we have your mean of 0.15. 2 standard deviations below is the 0.0848, and above is the 0.2152. Where does the 0.217 lay? It lays on the outside. When it lays on the outside, that means it is unusual. All right, let's do it according to the probability. So let's write the probability that x is greater than, you can write equal to if you want, to 26. So the reason why we're doing greater than 26 is because if 26 have hearing problems is unusual, then any number greater than that would also be unusual. And this is for x, but we want it as a proportion. So we need to convert that to your proportion. So we did 26 divided by 120 below, and that was 0.217. So we're greater than, so our lower bound is 0.217, upper bound 999. Mean was 0.15. And then standard deviation. So 0.02. And that is less than 0.05, so that is unusual. Okay, so either way you do this, your homework might ask for a specific way. But let's write out what it means. So the population proportion of Americans with hearing trouble who regularly listen to music using headphones is more than 0.15. Okay. I'm going to highlight that so hopefully you can see it. Sorry, this turned into a little bit of a mess. I don't know if that helps or not. Okay, so the reason why we use 0.5 is because we are looking for the mean proportion overall. Okay, right here. So let's go back to the overview sheet and cover what we just covered in 8.2 on there. Here we have our sample proportion. This is to check for normality, again our independence, and then here we have our mean and our standard deviation formulas. If you have any questions at all, please contact me or post to the discussion board.